Okay, the reason why I'm making this video is there's been some questions raised about the system in general, and mainly regarding the tape in the back and what it actually does in the system. So what I'm going to do is I'm going to develop, anytime you run into a physics problem, what you want to do is you want to look at it and determine the free body diagram of the system in order to make sure you're looking at all the forces applied. So what I'm going to do here, and forgive me, I'm not an artist, I'm an engineer, but I'll give it my best shot. Here's the plane, here's the tape that's stopping in the back, and there's your guideline with the straw, and there's the conveyor. Now what I'm saying is that the tape here, the only purpose of that tape is to provide a counteraction to the rolling friction caused by the bearings against the treadmill. Other than that, the tape serves no purpose. It allows me to run the treadmill without worrying about the plane falling off the back and having to control it with the thrust just to overcome the frictional forces. Now, whenever you look at a system, remember that acceleration, if acceleration is 0, that means the sum of forces is equal to 0. So you have the sum of the forces is equal to 0. Now remember, the forces are a vector. That means its magnitude and direction. So if you have the sum of the forces equal to 0, let's do the free body diagram here. You have the force in the normal direction and the force of the weight. Those two will cancel themselves out because the plane isn't falling and there's no lift applied at this point from the wings. So basically what we have there, those are going to be canceled out, and we're going to ignore those for the rest of the problems. Now what we're going to do is look at it with 0 thrust applied, and the only force that you would have is you would have the rolling friction of the bearings. And that's the only force that's there at that point in time. So let's say the treadmill is going at 4 to 10 miles an hour. It doesn't matter. Somewhere in there. The only force that's really on this system is the force and the friction. Now the thing that's counteracting that force in order for the sum to be 0 is you have the force of the tape. Now in order for there to be no acceleration, the force on the tape has to be equal to the force of the friction. So you can look at it mathematically, you have the sum of the forces equals 0, which is equal to, we'll have the x direction this way positive, so you have the F of the tape minus the F of the friction. So your force of the tape is equal to the force of the friction. So that's what you have. That means that you have 0 acceleration, and that's what you have in a free running system with no thrust applied. Now when you have the same system and you start applying a thrust, you have the force of the friction, you have the force of the tape, but let's say the thrust is not enough to overcome the force of the friction. You'll have the force of the thrust. So once again, you have 0 acceleration, so the sum of the forces is equal to 0, which is equal to F of the tape plus the force of the thrust minus the friction. So if you want to look at the force of the tape that's actually on the tape, you would have the F on the tape is equal to the frictional force minus the force of the thrust. Now, that is when the thrust is not enough to overcome the friction. As the force goes up, it's going to overcome the frictional forces, and eventually you're not going to have any force on the tape at all. And then the sum of the forces will not equal 0. And in order for that to happen, it's going to be going in this direction, and since I set up my XY axis this way, this being the positive, you have to have the force of the thrust must be greater than the force of the friction. And that is proven empirically with the system that I have on the treadmill. So what's happening here is, in conclusion, in the initial setup, with the conveyor going backwards, the tape provides a stopping force until I'm able to apply thrust to the plane. As I apply thrust to the plane, once the thrust overcomes the frictional force, what you're going to have is you're going to have motion in this direction, which you saw in the experiment. The tape doesn't do anything other than provide me some time and limit the amount of control that I need to do with the controller. So there's no smoke and mirrors here. Without the tape, all I would have to do is provide a small amount of thrust equal to the frictional bearing force, the rolling friction. And that's how the system works. So thank you.